All right, guys, we're going to talk about projectile motion. So this is what we talked about last week, but now we're actually putting the math to it. Okay, so projectile motion, that's when you maybe kick something, hit something, throw it, shoot it up in the air, drop it, or just project something into space and then it has to come back down. So that curve, like we talked about last week, will always be a parabola. Okay, so we're going to talk about 3 different situations that you might have. So the first type of projection would be that you have something that starts on the ground. Okay, so if I make an X and Y axis, typically we said Y axis is going to be height, X axis will be time, whatever the object is. But this would be something starting on the ground. So like at 0 seconds or minutes or whatever it is, there would be no height, right? Because it's starting on the ground. Something comes up and then it has to come back down. Okay, so generally, that would be one picture. Another one could be that something starts somewhere above the ground. Okay, so again, same thing. Height and time. But if something is starting above the ground, then at 0 seconds, it's going to be some height that's not 0, right? So maybe you're hitting a baseball, or maybe you have something in your hand, right, that's not on the ground and you're throwing it up. So maybe it starts there, goes up, and comes down. Okay, and then the third situation would be something falling from a maximum height. Okay, so again, you have height, we have time. So from a maximum height, maybe you're standing on top of a building and you're dropping something off of it, right? So that would start up high and then over time it would come down. Okay, so those are your 3 general situations. So each time we are given some situation, we're going to want to sketch that first, and that'll help us kind of figure out what's going on. Okay, so first example, we have an object that's launched straight up from an initial height of 5 feet. Okay, with an initial velocity of 32 feet per second, and then we're given a function. Okay, so we want to answer the following questions. So first one says, let's sketch an appropriate curve detailing the height of the object as a function of time. So sketch, again, doesn't have to be perfect. So I'm just asking which of these 3 situations we just drew is this. Okay, so if it starts from an initial height of 5 feet, then it's not starting on the ground. Okay, so I'm going to make my height and my time. Now, since I have a situation here, I'm going to put some units on it. Now, this does say 5 feet, so I know my height is in units of feet. And it says like velocity is 32 feet per second, so I know my time is in seconds. Okay, now of these 3, think about which one that would be, right? If the initial height is 5 feet, it's not the ground, so it's not the first one. So this is going to be starting from some height, and it does say it's launched straight up from there. Okay, so it's not the maximum height one, it would be the middle one. So something like that. Okay, so that's the first part, just sketch it. So the second part then is asking for the vertex. So this, again, goes back to what we were doing like last week, 2 weeks ago. So you have something in standard form, right? Here's your function. So it says find the vertex using x equals opposite of b over 2a. If you want to write your a, your b, your c on your function. Okay, so opposite of b would be negative 32 over 2 times a. Now a is negative 16. Okay, if you guys haven't already opened a calculator or grabbed a calculator, please do that now. So always do the bottom on this before you do anything else. Okay, so negative 32 on the top. 2 times negative 16, that is negative 32. And yes, you could use your calculator, but anything divided by itself is just 1. Okay, so remember, vertex is always a point. So we have 1 comma something. So remember, to get the something, we have to plug in what we just got. Okay, so back into your function. So this is negative 16 times 1 squared plus 32 times 1 plus 5. Okay, I'm going to go right to my calculator and just type that in. Okay, so I got 21. Okay, so that's all that question asks. Just find the vertex, right? So think about that on your graph. I'm just going to plot that on the graph. That would be the highest point. We know that that's at 1, 21 now. That's your vertex. Okay, so the next question then is asking you about that. So at what time does the object reach its maximum height? Okay, so this is what we did last week. Now we just put the numbers on it. So at what time? So I'm looking for the seconds or the x value, right? At what time did it reach its maximum height? Well, the vertex is its maximum height, so you're thinking, is that the 1 or is that the 21? So on the x-axis, right, that's the time, so that would be the 1. Okay, because this is your vertex. Okay, the next question, what is the maximum height? Well, that's the y value, again, of the vertex. Okay, so the y value is 21. So at what time did it reach its maximum height? At 1 second. What is the maximum height? It's the 21 feet. Okay, so far that all had to do with the vertex. The last part here is the part where we're going to need to, if you're on paper, we're going to need to squeeze some room in here. So when did the object hit the ground? So thinking about your picture, right here, right, would be where the object hit the ground. So I want you to think about what that's called on a graph, right? If it's touching the x-axis, then that's an x-intercept. Okay, so that's what this is asking for. When did it hit the ground? We're looking for the x-intercept. So you can have your foldable out, right? If you think about standard form, finding an x-intercept, that's when we're setting y equal to 0. Okay, so this is going to be 0 equals, now remember function notation, this really is y, right? So 0 equals that whole function. Okay, so it's negative 16 t, which is the same as x, squared, plus 32t plus 5. Okay, we have to solve that. Now, with this negative 16 in front, I'm not even going to try to factor that. Okay, that's going to be too much. And I'll tell you right now, it won't work. So if we can't factor, that's when we have to use the quadratic formula. Okay, so let's squeeze that in here. So quadratic formula is x equals opposite of b plus or minus big square root b squared minus 4ac all over 2a. Okay, you got a, b, c. So let's plug in our numbers. Okay, so opposite of b is 32. So opposite of that is negative 32 plus or minus big square root b squared, so that's 32 squared, minus 4 times a, which is negative 16, times c, which is 5, and that's all over 2 times a. Okay, just plugged in a, b, c. Okay, so now again, just like before, let's just figure out the number that goes inside the square root. Okay, so I'm going to go to my calculator and I'm just going to type in, not the square root part, but 32 squared minus 4 times negative 16 times 5. Okay, if I leave everything else, and we got the square root of 1,344. And then 2 times negative 16, that's negative 32. Okay, now before we were just leaving our answer like this. Okay, that was an exact answer. But I'm asking, when did the object hit the ground? This does not make a whole lot of sense to me, right? I don't know what that is. I don't know how many seconds that is. So now we're actually going to use our calculator again. So this part is new. Now I actually want you to type in the square root symbol. Okay, so this, I'm not going to do the negative 32s. I'm just going to do the square root of 1,344. Okay, you're going to get a decimal. That's fine. So I got negative 32 plus or minus. Let's go, let's just do one decimal place. Let's go 36.7 all over negative 32. Okay, again, this doesn't really make a whole lot of sense to me, so I need to do these, okay? I need to use the plus or minus, okay? So this means I'm going to actually do two separate things, okay? This is negative 32 plus 36.7 divided by negative 32. Okay, the other one is negative 32 minus 36.7 divided by negative 32. Okay, see the difference in that plus and that minus? Okay, so now we're going to go back to the calculator. Two ways you can do this. You can do it all as one, but if you do it as one, you better put the top in parentheses, okay, or just do the top and then do the bottom. Okay, so I'm going to do this first one. So negative 32 plus 36.7, that gives me 4.7. So now I'm going to do 4.7 divided by negative 32. Oops. Okay, so that gives me negative 0.1. Okay, now think about that. When did the object hit the ground? Can it hit the ground after negative seconds? No, that doesn't make a whole lot of sense. So that answer is not good. Okay, so I'm going to do the other one. Negative 32 minus 36.7. Okay, I get negative 68.7. So I'm going to do that divided by negative 32. Okay, this answer, again, I'm going to go one decimal place. I get 2.1. That one makes more sense, right? When did the object hit the ground? That's at 2.1 seconds. So that would be my final answer, okay? This is the real life stuff that you use this for, okay? Decimals, those are going to be more realistic than getting nice numbers. Yes, I know it's a lot of work, but it's stuff we've done before, okay? So that's the first one, okay? That's something being launched straight up from the air. Just for time's sake, maybe tomorrow we'll do number 2, but I'm going to skip down to number 3, and let's just do a different situation. Okay, so this one, a rock is dropped from an initial height of 48 feet. It's not going up from that, okay? It's just being dropped from a height of 48 feet. And then you have a function. Okay, so sketch an appropriate curve detailing the height of the rock as a function of time. So pick which of the 3 this one you think this one would be. Okay, you have height. This one says feet again. You have time and probably seconds, right? If you're dropping a rock. Okay, if you're dropping it from 48 feet, it does not say you're launching it up from there. So this is the one where it's starting up and it's just coming down over time. Okay, so it looks like that. All right, so what is the rock's maximum height? Okay, let's go ahead and do this kind of a long way and then we'll talk about it. Okay, so again, you could do vertex, right? X equals opposite of B over 2A. Now this function is a little tricky because there's only 2 terms. There's actually no t, right? There's a t squared and then there's a number. So this is like 0t plus 48. So I'm going to use that for my A, my B, my C. And then we'll actually talk about a shortcut you could use for this one. So opposite of B, well, if B is 0, I mean, you could put negative 0. That's the same as positive 0 over 2 times negative 16. Well, what's 0 divided by anything? It's 0, right? Now, if I go plug in 0, because I'm just doing the exact same thing I did on the last one. Plug in as zeros for all of my t's, because that's my variable. Well, guess what? 0 squared 0, that's going to go away. 0 times 0, 0, that's going to go away. So you're just left with 48. Okay, so think about that answer. If 0, 48 is your vertex, isn't that right here? So if something's being dropped from its highest point, that first point is the vertex. Okay, so what is the rock's maximum height? The y value is the height, so we'd say 48 feet. So if something's just being dropped and not thrown up, you kind of already have the vertex. You didn't have to do all that work. All right, when does the object land? Okay, again, this is going to be your x-intercept, right? So we're finding this point right here. So we want to know how many seconds did that take. Okay, so same thing here. So let's go 0 equals your function. Now I am going to put the 0 in there just so we can use our A or B or C again. And let's wrap this up with one more quadratic formula. Okay, so why don't you guys start plugging this in? You can do this as I do it. So opposite of B, again, that's just going to be 0, right? Or you could say -0, but that's the same thing. B squared, that's 0 squared, minus 4AC all over 2A. Okay, plug in just the inside part. So 0 squared minus 4 times -16 times 48. Oops. So inside the square root, we get 3,072. 2 times -16, that's going to be -32. Okay, so remember, next part is actually doing the square root part. So 0, it is 0 plus, but just plus or minus, oops, not the square root anymore. Let's do the square root of 3,072. Let's just go one decimal place. That's 55.4 divided by -32. You could still have this 0 plus or minus in front. Okay, so now remember we need to do two things. Okay, so this is positive 55.4 divided by -32, and then negative 55.4 divided by -32. Okay, so last thing here, why don't you guys type both of those in your calculator? Remember, one's going to be a good answer, one's a bad answer. Figure out which is which. Okay, so the first one, we should get -1.7. The second one, we should get -55.4 divided by -32. Oops. That's 1.7. Okay, so which one doesn't make sense? The negative, because you can't land after negative seconds. The 1.7 makes sense. Okay, so we would say at 1.7 seconds, the object hit the ground. Okay, we are going to do more practice with this tomorrow, but I know some people are going to be at Rise. And then on block day, we're actually going to do a project with this stuff. Okay, so you guys have a short assignment on Schoology right now. Okay, so this is the Unit 4B, Lesson 4, Day 1 exit slip. Okay, we're going to have another one tomorrow just for more practice. But this would be the Day 1 one. Okay? All right. Thanks for listening, guys. See you tomorrow.